Yeah, good morning, students. Today, I would like to discuss about diffraction. So, diffraction and conditions. So, before that, I would like to discuss about diffraction. My name is Allam Mallikarjuna, Department of Physics, Audisankara College of Engineering and Technology, Guru. So, some of the topics about the diffraction and conditions, classification of diffraction, Fresnel and Fraunhofer diffraction, Fraunhofer diffraction due to single slit, Fraunhofer diffraction due to double slit experiment, diffraction grating and grating spectrum, and applications of diffraction and various engineering segments. So, what is the diffraction? The word diffraction is derived from the Latin word diffrax, which means to break the pieces. So, diffraction, the phenomena of bending of light around the corners of the obstacle and spreading of light waves into geometrical shadow region of an object placed in the path of light is called diffraction. The diffraction example, colors observed in thin film and colors observed in peacock feathers. But the young double slit experiment, the interference of light is due to bending of light at the two slits. If there is no bending at the slits, there is no possibility of interference. So in this diagram, the plane wavelets it passes to single slit, and the light is dispersed to the like in a crust and trough waves passes to the screen. It is a maxima and minima intensities. The center spot is the maxima condition. It is a principal maxima. Another one is a minimum intensity position. Another one is secondary maxima. When the light is all the bright bands are same intensity, all the dark bands are zero intensity. Diffraction is a common characteristic property of all types of wavelengths, also propagates as wave so that has to bend around the corners of obstacle placed in the path. Because of its extremely shorter wavelength, such bending is not pronounced and hence light appears to travel in the straight lines. The diffraction effects are obtained and are observable only when the dimensions of obstacles are comparable with the wavelength of light waves concerned. The main causes of diffraction is limiting of wavefront by obstacle and an aperture. The conditions observe the diffraction. The size of the obstacle is much longer than the wavelength of light. Then it appears that light advances by a rectilinear propagation. So here the wave diffraction is that one. Another one is if the size of the obstacle is comparable with the wavelength of the light, then light is bent around the corners of the obstacle and spread out into the geometrical shadow region that is called diffraction. So what is the Huygens principle? Huygens principle is the diffraction phenomena was explained on the basis of the theory. According to this theory, every point on the primary wavefront acts as a secondary source of disturbance and secondary waves are generated from these points. To evaluate of these secondary waves from secondary wavefronts, that means every point of the source is source of a secondary wavelets. What is the difference between Fresnel and Fraunhofer diffraction? So Fresnel and Fraunhofer diffraction, the diagrams is as shown in the figure. The Fresnel diffraction diagram is here, there is no slits are used. And Fraunhofer diffraction, the slits are used. That means for diffraction to occur, the light source and screen both are the finite distance from the obstacle. And Fraunhofer diffraction, for diffraction to occur, the light source and screen both are the infinity distance from the obstacle. The study of diffractions lenses not necessary. The study of diffraction lenses is necessary to use the diffraction. The incident wavefront is either spherical or cylindrical shape. the incident wavefront of Fraunhofer considered as a plane wavefront. In frontal diffraction, diffraction can be studied only in the direction of propagation of light. The incident light of diffraction studies only direction of the propagation of light. The study of diffraction in frontal is complicated. The study of diffraction is easy. This is the major difference between frontal and Fraunhofer diffraction. Fraunhofer diffraction due to single slit experiment, we had to observe like in maxima condition, minima condition, and secondary maxima. So then in this experiment, you have to calculate the resultant amplitude R is equal to A sine alpha by alpha. In a Fraunhofer diffraction, the incident wavefront must be is a plane. Let us consider a slit AB of width is E. Let a plane wavefront is W dash of monochromatic light of wavelength propagate normally towards the slit is incident on it. The diffracted light through the slit is focused by means of convex lens on a screen placed in the focal plane of lens. According to Huygens Fresnel, every point of the source is a source of a secondary wavelets, and the light is dispersed to all the directions. But central point is a bright central maxima, that is OP naught is a bright central maxima. Then we will find the path difference at a P1 position. The path difference according to triangle ABC, BC is equal to AB sin theta is equal to E sin theta. And corresponding phase difference is 2 pi by lambda into path difference 2 pi by lambda E sin theta.